Bismillah. Hi. We are still at process control strategies. We are discussing the light loop. And what we did in the first 5 parts, we investigate how to use the Matlab Simulink with Arduino Mega to use it as in manual control, on-off control, P control, and PI control. Now, stage 2, we'll do exactly the same thing, but with the PLC plus an HMI. So I'll program the PLC and the HMI so that I can use the same loop, control the intensity of the light, manual control, on-off control, P control, and PI. And in stage 3, we'll do Arduino only using C programming. And stage 4, I'll show you some schematic how to do this with an op-amp. So the loop setup of our circuit will have a change, of course. We used to have an Arduino, now we have a PLC. I'm using a 71200 PLC connected to the HMI. My analog input here in the Arduino, if you remember, it was between 0 and 5 volts. The PLC has a default analog input which goes from 0 to 10 volt. So I'm changing the supply to 10 volt and using the same LDR and the same R. Now, my analog output is now in the PLC, it's a real analog output. It's not a pulse width modulation output. So I have two options. Either I put it as a current output or as a voltage output. The voltage will be from 0 to 10 volt, or a current will be from 0 to 20 milliamp. I chose to use a current because I don't need to use the current limiting resistor. My circuit will be even easier. So I'm using the PLC analog output as a current, so it will go from 0 to 20 milliamp and connect it directly to the diode. You have to remember the LED is a current device. So I'm using 4 to 20 will suit exactly what I want, and my circuit will be easier. You have the choice, of course, to put it as a voltage analog 0 to 10, but you have to calculate the current limiting resistor. So now we have to go to the manual mode. This is how the screen of the HMI will look like. I have only two fields. The field one is a control output. I will enter a value between 0% and 100%, and I'm showing the PV in voltage, of course. I don't have lumens, so it's in voltage. So, and exactly the same concept that we saw in the Arduino will apply here. In manual control, I have to control the control output in order to keep the PV at a certain set point in my head. There is no value, a set point in the manual control. You have to remember that. I repeat this in every manual control because a lot of students make a mistake with this. In manual control, there is no set point, the set point only in my head. So I will control, I'm the manual, I'm the controller. I'll change the control output till I get the PV to the value in my head, which I will call it set point in my head. So let's go to the PLC. How we will do this? First of all, I'll create a template. So if I go, I created a template one, and this is my template. I'm using, by the way, KTP 400. This is the hardware I have. If you want to know how to create a template like this, you can watch my other video, the template, and I'm explaining how to use, how to create a tabs for an HMI. The only thing that worth noting here that every one of those, if I go to properties, when I click on them, if I go to event, I'm setting a tag. There is a tag name called screen selection. It's changing value. So if I'm clicking on the manual, the screen selection value will be 2. If I click on the on-off, the screen selection value will be 3. And if I click on the P, it will be 4, and in PI will be 5. So this tag name will change value each time I press either one of those. And I'm also want to tell you that those actually two buttons overlapping. This one, it's the dark one. It's not only setting the value for the screen selection, but also activating the screen that I will call to show here. So I'll put this back to its place. Oops. So I'll put this back here. And let's go to my screens and clicking on manual. So here in manual, I added a field for the control output and a field for the PV. Now let's go to the main in the PLC to see how this works. So I'm here in my PLC. I'll add a comparison between the tag we just saw. I called it in the PLC a screen number tag. It's the same one, screen selection tag. I saw it there. I equaled it in the HMI. I told him this tag is equal to this in the PLC, and I'm comparing this value with the number. If this value is 2, remember when I press the manual button, the value will take 2. If this equal to, then call the manual function. If it is equal to 3, call the on-off function. If it is equal to 4, then call the P control function. And if it is 5, call the PI control function. Also, there is a video how to use function on an S7 1200, but it's very simple. Just double click and add a new block, and you select function and you name that function, and voila. The only thing why I'm doing here, it's just it's easy to organize my code. So if there is some problem in manual control, I'll just come here and check. So if I double click the manual, I'm now in the manual. See the tree? I'm inside the manual function. So when it is true, I'll come here. What I'm doing here, the first, I'm checking the value, that the control output value I'm entering. If it is higher than 100, then move 100. And if it is lower than 0, then move 0. So this is just a cap, not to allow the user to enter a value beyond 100 or lower than 0. Now, I'm taking the value the user will enter. It's between 0 and 100, and I normalize scale it to MD14 manual output value between 0 and 26,000 something, which is the maximum of my PLC analog output, which means also the 26,000, the 20 milliamp. And I'm moving this value to QW80, which is the address of my analog output. Now, let's see this in action. I'll go online to check the value. I'll go back to the manual, and I can see here, I'll monitor. I can see my screen number value is 2, so it's calling the manual function. I'll change it in the HMI. I'll press on off, and you'll notice right away the value changed to 3. So this condition is not true anymore. So the PLC program, the CPU, will not call the manual function, actually will call the on-off function. And if I press the P, it's now 4. So I'll press back to manual, and in manual, it's calling the manual function. So if I go enter, I can see now the values and moving it. Actually, the simple way to see this, I'm creating a wash table. I'm going to a wash table, and in the wash table, I'll add the variables I want to monitor. It's the best way. It's the easy way. I already created some of those values. Some of them I need now, like the analog input, the analog output, the screen number, the PV, and of course the manual I/O. And some of them I'll need in the next videos. We will see them later. But right now I can see my analog input value is 2000, which is the same as my PV. So I'm changing my PV. It's almost 0.72. You have to remember, my PV is between 0 and 10. I can't go to 10 to 0, and I can't go to 10. It's a value between. It's a range. The same way it was with the Arduino. I can't go from 0 to 5. It's a range between those. So I will increase the value of the control output in the HMI. I'll give it like 50%. I'll press enter, and you can see right away the value now it's 50%, and my PV it's already on 9.8. Actually the value is not linear, we can find this right away. And my analog output value is almost the half of the 26,000 or 27,000. So makes sense. I have now 50% of output. I'm reading a value in PV. I'll change it to 10%, and you can see it's 8. So it's really not linear. I'll give a value of 1, and with 1, I'm getting 3, 2.6, 2.5. I'll enter 2. Actually, I'll enter 3. And we can see the value is changing to 4. So it is really not linear, the same way we saw it in the Arduino. But you have to keep in mind, what I want to do in manual control is actually changing the value of the analog output or the C out till I get in the PV the value in my mind. So if in my mind I need to have 6 volt, I will change this value till I get 6 volt. So probably 4 will do the trick. 4. And if there is some lights, I need to reduce this number or increase it. And this is the way. So this is manual control.